All right. So let's just start with this. I think we'll just go quicker than we normally have to. Um, I'll just get to the point. But let's look at this example to get an idea of what we want to do. So assuming each interval on the graph represents 1 unit, find each of the following segments by counting, if possible. Okay, so we want the length of AB. And each segment from here to here is 1 unit. So how many units long would AB be? How long is AB? 6. 1, 2, 3, 4, 5, 6. That's easy. Okay. How about AC? How long is AC? Well, let's see. We know each side length, so going vertically or horizontally, it's 1 unit this way going horizontally or 1 unit vertically. What what's our problem here? What hmm? Yeah, it's slanted. It's horizontal. So just even here from going from here to here, that's a little less than 1 unit, right? And that's really small. It's just kind of difficult. And I just realized, sorry, I had my anime club, and you guys don't have calculus. Zoom. Um, how can we find the length just by counting? Is that possible? Yeah. Okay. Ooh, yeah, that still seems like a lot of work. Maybe then we'll come back to this question. Let's answer this one. Explain how a right triangle could be used to help answer part B. That a right triangle, what part of a right triangle does AC look like? Hypotenuse. So if we form a right triangle, I went a little over. Do you see how we could find that length now? Assuming we could find the length of each leg, is that possible? Yeah, that's easy, right? Because we're going from -2 up to 4, right? And then we're going from here to here. So we could figure out this length, and we could figure out this length. And those are just legs of a right triangle now. Because luckily for us, that's a right angle. So let's just answer this. For this, we're going to say very difficult. Almost impossible by counting. And what can we say for explain how a right triangle could be used to help answer part B? What are we basically doing here? We're form a right triangle, and yeah, let's say AC will be the hypotenuse. All right. So that's the technique we're going to be using. Um, and let's just talk about it. To find the diagonal distance on a coordinate plane, create a right triangle where the diagonal is the hypotenuse, or as we all call it, C. Then use um, a. It's Pythagorean theorem, but let's just write down a squared plus b squared equals c squared to calculate the distance. And that would basically give us the distance exactly or very accurately. We could leave it as a square root if it's irrational, or we could estimate it rounded to some number like the nearest tenth or hundredths or whatever they need us to, and get a very accurate distance. Okay, so let's practice this. Move it on up. And what we're going to do is let's find the distance of AB here. So in order to do that, we need to form a right triangle. And you can either start at A and go up and to the right, or start at B and go down and to the left, whichever you prefer. But it has to be straight up and to the right or straight down and to the left. They need to form a right angle. And now I'm going to measure my distance. This is 5, 4. Okay. And this is going to be, I'll call it C. And now we can just set that up. So I'm going to get 25 and 16 equals C squared. And that's 41. So that means, what is C going to be? Oh, okay, you're already getting, what is it exactly though? Yeah, exactly, it's the square root of 41. And we're going to approximate it with the calculator to one decimal place. So we want the square root of 41. What was that? 6.4. Yeah. The exact answer is square root of 41, but that's not real useful if we need a number there. Square root of 6.4 is going to work better. Okay. So I want you to try 2 and 3. Practice what we just did. Okay. I'll give you some time to do that. For number 2, I got the square root of 53, and the approximated answer I got is 7.3. Okay. No, no. Um, so I noticed for number 3, and I don't do this with the 8th grade, with the regular 8th grade class, but you guys are going, some of you will go into geometry, so this is important. I noticed it was 8 and 8, so it's going to be 8 squared plus 8 squared. So I just wrote it as 2 times 64 instead of 128, because I know that 64 is a perfect square and I could factor it out. So for the exact answer, if you wrote square root of 128, you can factor that. You can simplify it. And the answer should be 8 radical 2. Um, I just did that in advance, knowing that, okay, I'm going to have to simplify the square root. So it's either 8 radical 2, and when you multiply 8 times the square root of 2, turns out to be 11.3. Okay? So the distance across is 11.3, or 8 radical 2. All right. So there's our 3 answers. So I'd like you to try, it says triangle EFG is shown on the grid. Find the length of EG. And suppose they ask you to find the perimeter, so you would definitely have to do that. In fact, let's find the perimeter. Since they were kind enough to already set up all the different lengths, let's find the perimeter. Because what do we have here? This is 9. This is 3. Let's find EG. So to find that, we want 9 squared plus 3 squared equals EG squared. And EG just means the length of EG. So this would be 90. And square root of 90 is 9 something. 9.5. We'll round it to 9.5. Okay. So remember what we have to do for the perimeter? Perimeter is just the sum of all the sides. So let's just do that. So we want 9 plus 3 plus 9.5. And how much is that? $21.5. So the perimeter for this triangle is 21.5. Okay. All right. You guys ready to go to number 5? So on number 5, 5, 6, and 7, they're just giving us coordinates. Tell you what, let's just do 5 and 6. I think if we can do 5 and 6, we're good, and then we'll move on to 8. We'll skip 7. Let's plot the points and figure this out. So we want -6, 1, and -4, 5. we want this distance here. It should be a pretty small number. Um, so 2 and 4. So we got 20. Ooh, we can simplify 20, by the way. What two numbers multiply to give you 20 where one of them is a perfect square? 4 and 5. So one answer should be 2 radical 5. And then the other answer is, well, square root of 20 is also 4.5. So it's about 4.5 as well. Okay. All right, let's try. Go ahead and try number 6 on your own. So plot the points and let's figure it out. Okay, and the other point is 4, -3. Hmm. Okay. I'll give you another minute or so. What's the exact answer for 6? Anybody got something? Yeah. Well, that's the approximate answer. That's when after you take the square root and use a calculator, you're approximating, right? Because yeah, you got 11.7, which is great. That's the approximate answer, but the exact answer is a square root of 137. It may not be too useful as a number to calculate here. So if you're building a wall or a ramp, you want 11.7, but the exact answer would be square root of 137. Okay, let's move on to number 8. We got a pentagon on the grid represents the front view of a dollhouse in Kaylin's toy room. Use the grid to answer A through B. Okay. Each unit on the grid represents 1 centimeter. Okay, so each unit's 1 centimeter. So we want to find the lengths of the segments below. So we want AB Ooh, that one's going to be a little tricky. You got to use the Pythagorean theorem for that one. And BC should be the same answer because they're congruent. Then we want the other parts. And then we're going to get the perimeter. So work on that. Find each of these segments, AB, BC, CD, DE, and EA, and then we'll get the perimeter. Okay? So we'll have to, we're lucky in that both triangle parts, well, the lengths that form triangles, are the same size, they're congruent. Hmm. So it is like a 3, 4, 5. So this is 3 times 2, this is 4 times 2, this should be 5 times 2, or 10. Makes this 10. How long is this? 5? How about DE? So we got them all. This is 10, 10, 5, 12, and 5. So what's the perimeter? How much? 42 centimeters. Okay, in the graph below, point A represents Aria's house, point B represents Bridget's house, and point C represents Capri's house. Each unit on the graph represents 2 miles. To the nearest tenth, find the distance of the most direct path between each of the pair of houses. So we want the distance from Bridget to Aria to Bridget's house. So that would be this distance. So each unit represents 2 miles. So what's our game plan here to figure out that distance? Well, we should figure out the distance, form the right triangle, figure out the distance between the points. But then after we get that, distance, what do we have to do? Multiply by 2. It's a factor of 2. You should multiply by 2. Yeah. Because we went from 1 to 7. Negative 1 to 7. Okay, so figure out that distance and then multiply by 2. And then do the same thing to find Bridget to Capri's. And then Capri to Aria's. Oops, I did a horrible job of doing that triangle. Okay, so basically you find each length and use a scale factor 2 miles per unit.